we're going to be dealing with an exponential base called E, which you may have seen in intermediate algebra. And there is some information here. It's Leonard Euler. Euler's big physicist mathematician, has lots of stuff named after him, who discovered E and calculated its value to 23 decimal places. It's often called Euler's number, like pi. It is a transcendental number. It also means it is an irrational number. This means it's not the root of any algebraic equation with integer coefficients. Now, what really and where it comes from is this, that E really becomes the limit as n goes to infinity of 1 plus 1 over n to the n. This is what essentially E is, and it never stops, it never terminates, never repeats. It just goes on forever and ever. And so we can deal with this guy. Usually I take him down to 2.7 if I'm graphing as an approximation. Or of course your calculator does have E on it, and E is right above natural log. You'll see E to the x. So E is there. E is also over here above the division, but that's just E by himself, not E to any power. So what would he look like? Well, he is a number, 2.7. He's an exponential function. So if I were to look at x e to the x, negative 2, negative 1, 0, 1, 2, this would be e to the negative 2, e to the negative 1, e to the 0, which is 1, e to the 1, that's just e, we'll say 2.7, and e to the 2, e to the 2, that's not a 2 to the 2, but an e to the 2. And of course, if I want to bring it through, we'd say second e to the negative 2, which is about 0.1, because I'm graphing. And then to the negative 1, which is 0.4. And then e squared is 7.4. So e to the negative 2 is 0.1, e to the negative 1 is 0.4, e to the 0 is 1, e to the 1 is about 2.7, and e squared is off my graph paper, and that's what he looks like. Typical exponential function. As x goes to infinity, e to the x goes to infinity. As x goes to the negative infinity, e to the x goes to 0. His domain is all real numbers. His range is 0 to infinity. And he has an HA at y equals 0. Now, how do we deal with exponential equations? One of two ways. The first way is using the principle of exponential equality, which says that if a to the x is equal to a to the y, then x equals y. So that means that the bases are the same. Means exponents equal. So here the bases are the same. That's 3. So that says that 2x minus 3 equals x plus 2. The exponents are equal. X minus 3 equals 2. X equals 5. Now here the bases are not the same, but 64 can be written to a base of 2. This happens to be 2 to the 6th power. So that 2 to the x squared minus 3 equals 2 to the 6th. The bases are the same. X squared minus 3 equals 6. X squared minus 9 equals 0. This is x minus 3. x plus 3 equals 0, so x equals plus or minus 3. Now I need to use the properties of log exponents. It says that a to the m to the n power, you multiply the exponents. So this says that e to the 5x minus 1 equals e to the negative 6x. The bases are the same, so 5x minus 1 equals negative 6x. Negative 11x equals 1, or positive 11x equals 1. X equals 1 over 11. You cross-check that. If I were to move, well, that's the way I would want to do it. Move that over, becomes 11. Move that over, becomes negative, becomes 1. So that x is 1 over 11.